Meet the ESP32, a tiny, affordable brain for connected projects. It can read sensors, control motors and lights, and communicate over Wi-Fi or Bluetooth. In this topic, you'll see why it's so useful in robotics. So far, we've learned that a robot follows a basic pattern. It senses information, processes it with a controller, then responds through outputs like motors, lights, or sounds. The ESP32 is the controller that will connect those ideas to real builds, including a traffic light, a smart lamp, and a mini weather station. The ESP32 is a small computer you can build into electronics projects. It runs the code you write, reads inputs from sensors, and controls outputs like lights, buzzers, and motors. Think of it as the brain of a project. It notices what is happening, decides what to do, then acts. What makes it especially powerful is that Wi-Fi and Bluetooth are built in. Inside a robot, the ESP32 acts as the decision center. Sensors and buttons provide input, such as distance, light, sound, or a user press. The ESP32 reads those signals and uses your code to decide what should happen next. That decision becomes output, turning on an LED, sounding a buzzer, or driving a motor. With wireless communication, the robot can also send data, receive commands, or interact with apps and other devices. The ESP32 is useful because it combines several important jobs on one board. GPIO pins can switch simple devices like LEDs, buzzers, and relays, or read basic digital sensors. Analog inputs handle values that change smoothly, such as light level or temperature. PWM outputs create controlled pulses for dimming LEDs, changing motor speed, or making tones. And with built-in Wi-Fi and Bluetooth, your robot can connect without extra hardware. GPIO pins are the ESP32's hands and senses. They can read the world, like a button press or motion sensor signal. They can also control the world, like turning on an LED, sounding a buzzer, or switching a relay. In code, every connection is referenced by its pin number, so the number in your program must match the wire you connect. One important habit is to check the pin before using it. Some ESP32 pins have boot or communication roles, and using the wrong one can cause confusing behavior. Digital pins work with two clear states, high and low, like a light switch being on or off. As an output, the ESP32 sends a signal outward. High might turn an LED on, and low might turn it off. As an input, the ESP32 listens instead. A pressed button may read high, while a released button may read low, depending on the wiring. This two-state control is the foundation for alarms, switches, traffic lights, and many beginner robot behaviors. Not every sensor is simply on or off. Analog sensors report changing levels like light fading, temperature rising, or soil becoming wetter. The ESP32 reads that electrical signal and converts it into a number your program can compare. A low light reading might mean darkness, while a higher reading means bright conditions. Once the value is in code, the robot can choose smarter behavior, move forward, slow down, stop, or react when conditions change. Analog input turns the environment into data. PWM, or pulse width modulation, lets the ESP32 create in-between output levels using a digital pin. The pin is still only turning fully on and fully off, but it switches so fast that the device responds to the average power. A short on time gives low average power, so an LED looks dim. A longer on time gives more power, so it looks brighter. The same idea can control motor speed, buzzer intensity, or servo-style signals. The key setting is duty cycle, the percentage of each cycle spent on. Wireless communication is one reason the ESP32 stands out in robotics. With Wi-Fi, a robot can join a local network, send sensor readings to a dashboard, or receive commands from an online service. With Bluetooth, it can talk directly to nearby phones or tablets, which is useful for setup, manual control, or short-range monitoring. This turns a standalone robot into a connected device that can share data, follow remote instructions, and become part of an IoT system. Different boards are better for different jobs. The ESP32 is a strong choice when a project needs wireless communication, sensors, or IoT features, like a smart home device or connected robot. Arduino is often the easiest starting point for basic electronics because it is simple, reliable, and great for controlling LEDs, motors, and switches. Raspberry Pi is closer to a small computer, so it fits camera work, AI experiments, image processing, and software-heavy projects. Start with the goal, then choose the board. Controller choice starts with the job, not the board. If the project needs sensors, outputs, and wireless communication, the ESP32 is often the best fit. If the goal is basic timing, buttons, LEDs, or motors with very predictable behavior, an Arduino keeps things simple. If you need a camera, AI, a web server, or heavy processing, use a Raspberry Pi. The engineering skill is choosing the simplest controller that meets the requirements reliably. Before uploading anything, make sure the ESP32 is connected with a USB cable that can transfer data, not just charge. Then tell the coding software which board you are using, such as an ESP32 dev module or the specific model in your kit. Next, choose the port so the computer knows where to send the program. If the upload fails, don't panic. Check the cable, board choice, and port again. Whether you use blocks or text code, these setup steps are the gateway to controlling real electronics. Blink is the hello world of microcontrollers. The ESP32 first sets one GPIO pin as an output, so it can control voltage on that pin. Then the program sends the pin high, which turns the LED on. After a short delay, it sends the pin low, turning the LED off, then waits again. Because those steps repeat forever, the LED blinks. If you see that blinking, you know the board, cable, driver, code, and upload process are all working together. This same pattern becomes the foundation for traffic lights, buzzers, and smart devices. You now know what makes the ESP32 such a powerful controller. It reads inputs, runs code, drives outputs, and connects through Wi-Fi and Bluetooth. With GPIO, analog sensing, digital control, and PWM, it can interact with the real world. Next, you'll turn these ideas into projects: a traffic light, smart lamp, and weather station.